Yo, what's up? I hope all of you had a wonderful Memorial Day weekend, and you're ready for that final push towards the end of school. I believe, including this one, we have, I think, 5 class periods left, maybe 6, but I'm not 100% sure. Today we're going to talk about probability. We sort of leaned into this with our possible combinations, our permutations, and combination stuff. And all probability really is it's the chances that something happens. All right? So, some interesting things about probability. It's always between 0 and 1. All right, and this should make sense. 0 means something has a probability of 0. That means it cannot happen. It's never going to happen. And probability of 1, that means it's definitely going to happen. All right, so you can have a probability of 0, which means what's the probability that we have a in-school day the rest of the year? It's right now 0 because it's already been canceled. Probability of 1, that means it's 100% chance of happening. What's the probability that I'm wearing a gray shirt from Mercer County Basketball? That's 100% or 1. All right, probability is the number of successes over the total combinations. So if I were to say, what's the probability when you flip a coin of getting heads? All right, well, there's one way to get heads. There's 2 possible outcomes, heads or tails. So the probability of getting heads when you flip a coin is 1 out of 2. All right, the most basic probability problem there can be, which is flipping a coin. And I apologize, I made a video for you in the middle of the woods, but unfortunately there were some technical difficulties, so when I got home, that hadn't worked, so we're back in my basement. Sorry. It was pretty fun. So there are 2 types of probability that we're going to talk about. And the first one is called experimental probability. And what this means, experimental probability, is what actually happened. All right, so let's say I flip a coin 10 times and I get 8 heads when I flip it 10 times. My experimental probability of getting a heads when I flip a coin is 0.8 or 80%. The other kind theoretical probability, that's what should happen. All right, and that for flipping a coin is our 1 out of 2. So 0.5 should be your theoretical probability when flipping a coin. Now, one of the more powerful, the most powerful, I should say, concepts in mathematics, we may have talked about it earlier in the year, and that's something called the law of large numbers. And what the law of large numbers says is that as the number of trials, we'll call that n, grows very large, the experimental probability approaches the theoretical probability. All right, and this sort of makes sense. Basically, what it's saying is that we'll stick with flipping coins because it's the easiest example. But if I do 10 flips of a coin, there's a decent shot I might get 8 heads, all right, for a experimental probability of 0.8. But if I flip a coin 100 times, it's very unlikely that I'm going to get 80 heads for an experimental probability of 0.8. All right, am I going to get 50 out of 100? Probably not, but I'm going to get a lot closer to that theoretical probability with 100 flips than I would at 10. And if I flip 1,000,000 times, there's almost zero chance that I get a probability of 0.8, meaning 800,000 out of 1,000,000 flips would be heads. That's just not going to happen. All right. So what the law of large numbers says is that the more times I do something, the more likely it's going to get close to that theoretical probability. All right. And this is a really powerful concept. All right. I've probably told you before, I am a poker player. And what I try to do whenever I play is make the correct mathematical decisions. Well, now the thing is, those decisions may not work out every time, but if I make the correct mathematical decision every time, then over the long haul, I'm going to win a bunch of money. In the short term, I may lose one specific time, right? I may lose 3 times in a row. But if I play enough hands, then, and I'm making positive expected value decisions, then that are theoretically plus money, then I'm going to make a bunch of money. All right, if you go to a casino and play casino games, all right, the house has an advantage in every casino game except for if you're counting cards and blackjack. Now, you may win if you play a casino game once. You may win if you play a casino game 5 times. You may win 4 of them. But the more you play, what's the law of large numbers is going to get you, and you're going to end up losing money unless you're an advantage player. All right, for those of you who have taken calculus, you could say the limit as n approaches infinity, all right, of your experimental probability equals your theoretical probability. So a little limit. As we get close to infinity trials, your experimental probability will equal to your theoretical. Let's just look at a couple quick cases and just kind of hammer home what probability means again. All right, you may have heard, all right, of our coronavirus, our COVID-19. So I believe the latest numbers are saying that 5.5% of all tests are positive. And what that means is there's a probability, an experimental probability, of a positive test equals 0.055. All right. Now, what does that mean? Does that mean that 5.5% of all of the people in the country have coronavirus? No, because not everyone was tested. All right. Does that mean that if I test exactly 100 people, 5.5 of them are going to have it? No. First of all, you can't have 0.5 of a person. And second of all, our sample size of 100 is not that large. Now, we have tested a lot of people in the millions at this point. So N is getting larger. So we're getting close to the theoretical probability. The problem is our sample is not what we call a random sample. We'll get into that later. But you're more than likely, if you're getting tested, a lot of those people already have symptoms. So what this probability means, this is just an experimental probability for right now, but it doesn't necessarily mean that 11 out of every 200 people have it. What that means is, of all the tests we've done, 5.5% or a probability of 0.55. All right, you may be, we talked a little bit about casinos before, you may have seen a game called roulette. What roulette is, you can Google it if you like. There's a little wheel, and there are 38 spaces on the wheel. All right, you put a little ball in, and it goes around, and it stops in one of those 38 spaces. Basically, there are 18 black spaces, 18 red spaces, and then 2 green spaces, which are 0 and double 0. And essentially, there's all different types of bets you could make. But one of the bets is, say, I bet $5 on black. Well, if one of the black numbers comes up, then I win $5. If one of the other numbers comes up, then I lose my $5. So the probability of the ball landing on a black space, well, there are 18 blocks out of 38 total spaces. So my probability is 18 out of 38, or 9 out of 19. Don't seem to have my calculator handy, but it's probably about 0.47 or so. Now, again, law of large numbers. If I bet black, I may win once. I may win 3 in a row. I may win 8 out of 10 times. However, the more I play, since I'm only getting back the amount of money I bet, the more times I play, that sample size, the law of large numbers kicks in, and I'm going to start losing money. So this is not a good bet, not something I would play ever. This is what we call negative expected value. I don't think, unfortunately, we'll get to that during the course. All right, so that's our intro to probability. Be a short, pretty easy assignment. This time we're going to go a little farther in depth into this over the next couple of class periods. We're going to get a little more complicated. All right, have a wonderful day. Later.